Welcome, learners. My name is Mr. Paul Chilola, your teacher on this platform on Black Slides Online Secondary School. Right, so remember it is on this platform only where you come and learn the sciences to prepare you for your Msce examinations. Whether you are in Form 3 or you are in Form 4 yet to write your Msce exams in the year 2026, welcome to this platform. It is a platform where you learn the sciences, namely biology, physics, and the chemistry, as well as mathematics. So once again, welcome. If you are in Form 4, preparing to sit the 2026 Msce exams, welcome to this lesson. This lesson is for you. We are going to be looking at a Form 4 topic. This is a Form 4 topic, Form 4 physics, which is called light and thin lenses. So just light and the lenses. Remember that the topic light and lenses is an extension of the broader topic waves and oscillations. All right, so welcome to this component of waves and oscillations, which is called light and lenses. It's Form 4 physics. You are most welcome once again. If this is the first time you have visited the channel, Black Slides Online Secondary School YouTube channel, consider subscribing to the channel so that you don't miss on anything that we post in the future. It is for the love of my students that I prepare this lesson. This lesson is as a result of the public call or public demand from my students, my online students. So welcome once again. All right, like I always say, it is important for us to define the topic in order to have a thorough understanding of any topic. It is important to define some concepts. This is called the principle of first mention. The principle of first mention states that for you to have a thorough understanding of any topic, it is important to define the topics, the terms that relate to such a topic. So one of the key terms that you need to have a thorough understanding about is the term lens. Of course, it is one of the minor questions. The examiners cannot ask you to define the term lens. No, that will be too cheap to ask students to do. All right, but for the sake of explaining this topic, it is important, it is ideal for me to define the term lens. What is a lens? I'm sure you have seen lenses before. Lenses are found in many gadgets that we use every day. In your phone camera, you have a lens. If you have a DVD player, you have a lens there. If you have a digital camera, such as a compact or any other beautiful camera, you must have lenses in it. Lenses make things look beautiful in a camera. All right. So we define a lens as simply a transparent material with at least one curved surface. All right, so that's a lens, definition of a lens. All right, we are saying a lens is simply a lens is simply a transparent material with at least one curved surface. It is enough to define a lens like that. So a lens is a transparent material. What does it mean to be transparent? Transparent simply means allows light, yeah? Allows light to pass through. All right, so it's a material that can allow light to pass through it. Any material that allows light to pass through is called transparent material. Of course, it should be able to see through it as well, because there are some materials that, yes, allow light to pass through, but you can't see through them, like some kind of glass. We call that translucent materials. Translucent materials, like glasses that are used in toilet windows or bathroom windows, allow light to pass through, but you cannot see through. So those are special glass which are called translucent. So here we are not looking at translucent glass or translucent materials. We are looking at lenses. Lenses by nature are made of transparent material in order to allow light to pass through them. So lenses can be made of glass. They can be glass, or sometimes you can have plastic ones also. All right. So lenses are classified into two main types. We have two main types of lenses. Namely, we have what is called the convex lenses and the concave lenses. The naming of the lenses as convex and concave lenses is decided by their shapes. All right. It is the shape of the lens that decides the name. All right, so let's look at convex lenses. As a matter of fact, convex lenses are also called converging lenses. Convex, converging is the same. So by nature, convex lenses or converging lenses are thicker in the center, at the center, and thinner at the edges. This is how you would recognize a convex lens is one that is thicker or fat, shaped like this. This is a convex lens. So here it's thick, but on the edge here is thin. Right, so that's called that's one nature of convex or converging lenses. Convex or converging lenses can be classified into three categories. Namely, we have what is called a biconcave lens. This type of lens here is biconcave or biconvex, biconvex lens. This is called a biconvex lens. The shape of a biconvex lens is curved. It curves outwards on both sides. Bi means two. Bi means two. So convex means having surfaces that curve out on both sides. So this side is curved outwards. This end is also curved outwards. Therefore, it is called biconvex. Bi means two. Two surfaces that are curved outwards. All right. Apart from biconvex lens, which is a type of convex lens or converging lens, we have plano-convex lens. Plano-convex lens. The word plano is from plane, which means flat. Plano is derived from the word plane, which means flat. So it has a flat surface. This end is called plane, from which we get the first part of the name, plano. And the other side is curved outwards, is convex. Is convex. To be convex means to be curved outwards. All right, like that. Okay, so plano-convex comes from the fact that one side is plane, which is flat, and the convex means the other side has a side which is curved outwards. All right. I hope we're together there. The third type of convex lens is the converging meniscus. Converging meniscus. So one end is curved like a meniscus. You learned about meniscus in Form 1 when you were learning about the 3 states of matter. One of them is liquids. For example, water. When you place water in a container like this, it is curved like this. So this shape is called meniscus. Meniscus, eh? Yeah. So the shape of the convex lens called converging meniscus is such that one end is converging or convex or curving outwards, while the other end has a shape of a meniscus. Therefore, the type of convex lens we have is called the converging meniscus. Once again, we have 3 types of convex lenses. Namely, we have what is called the biconvex, plano-convex, and the converging meniscus. I hope we are together up to this point. All right, so the nature of convex lens, or the behavior of the convex lens, is such that when parallel rays of light strikes a convex lens, all right, they're saying when parallel rays of light strike a convex lens, they converge to a point behind the lens called the principal focus. All right, so we are saying rays of light that are parallel to one another, when they strike a convex lens, they converge. They converge. To converge means to come together. Come together. Or meet at a common point. To a common point. To a common point. To one point. All right, that's to converge. And it is from this action that we get their name from, which is called the converging lens. All right. So the rays are reflected towards where the lens is thicker. Okay? So we are saying that when a parallel beam of light, so these are parallel. It's called a parallel beam. Parallel beam. Remember that a beam is just a group of rays of light. So when they strike the lens, this is our lens, convex lens, they are going to bend. They are going to bend. They are going to bend, and they are all going to travel to a common point. To a common point, all right? To a common point where they meet. Where they meet. So this point here is known as the principal focus. The principal focus. All right, so we can show this behavior of light, or the action of the lens. Okay, this is what we are talking about here. All right. So we have a lens here, which is a convex, and we are saying that when light rays strike it, it will cause the rays to meet at a common point. At a common point. At a common point. All right, this is what we are talking about. All right. So we have rays of light. Rays of light here. These are rays of light that are coming from a point such as this pencil here. All right, so upon reaching the lens, this is our lens, okay, they are going to bend, and upon bending, they are going to meet at a certain point. At a certain point, which is called the focal point. Focal point. This is called the focal point, which is given the letter F. Focal point. All right. Focal point. So that's what we are saying, basically. So the rays will bend. What is happening there is a process called refraction. Remember, refraction is the bending of light. When it passes through two different media, or media of different optical densities, refraction is going to happen. So upon being refracted or bent, so refraction happens here, it also happens here, and then these rays are going to meet here at the focal point, also known as the principal focus. The principal focus, at the principal focus. All right, so that's what we are saying. If this is the first time you have visited the channel, don't hesitate to consider subscribing to the channel. So that every time a new video is uploaded, you become the first one to know. Alright, so we've looked at the definition of a lens, and we've seen that there are two types of lenses, namely convex lenses and the concave lenses. And the convex lenses can further be divided into two. Alright, can further be divided into two, namely, into three, sorry. Namely, we have the we have what is called biconcave lens, in which both sides are curved outwards. And then we have plano-convex, whereby one side is flat, the other one curves outwards. And then we have meniscus converging lens. All right, so those are just types of lenses. All right, now we come to another type of lens, which is called we have to another type of lens, which is called you beg your pardon. All right, which is called concave lens. Concave lens. So a concave lens is one in which the edges are thicker and the center is thin. All right, so a concave lens is one that is shaped like this. So the shape of a concave lens is simply something like this. So it is thick here, but in the middle is thin. That's how you recognize a concave lens. Remember that a concave lens is also called a diverging lens. So by definition or characteristic, they are thicker at the edges and thinner at the center. All right? So you do recognize a concave lens by that nature. Also, concave lenses can also be classified into three categories. Namely, we have what is called biconcave lens. Biconcave means both sides are curved inwards, not outwards, but inwards. Since we have two sides, we say bi means two, concave means curving inwards, like that. Curving inwards. And then we have plano-concave, whereby you have one side which is flat. Remember, plano is coming from the word plane, which means flat. Yeah. So one end is flat, while the other end, the other surface, is curved inwards, concave. Concave means curving inwards. And then we have diverging meniscus. So it's curved outwards one end, and it curves inwards on the other side, which makes a meniscus. So make sure you know these classifications of lenses. The examiner can ask you to simply sketch any one of them in a 1-mark question. All right, so you should be able to do that without problems. The action of when parallel rays of light strike a concave lens, they diverge as if they appear to come from in front of the mirror. Okay. We are saying that when parallel rays of light strike the concave lens, they diverge. To diverge means to spread, as if they appear to come from in front of the mirror. Okay. So this point is the principal focus F of the concave lens. Okay, what it means is, if we look at rays that are parallel, these rays are parallel to each other. They're parallel, coming from somewhere like that. upon reaching the mirror, they are going to spread or diverge like this. They are going to spread in different directions as if they are being sent from somewhere common. All right, so they are going to be spread in different directions. Now, these rays seem or appear to be coming from a common point. They appear to be coming from a common point. All of them appear to be coming from a common point. They all seem to be coming from a common point. So this point here is what is known as the principal focus. Principal focus. Okay, denoted by the letter F. All right, so that's the action of the of a concave lens. All right, let's continue looking at more terms used in lenses. All right, for a convex lens, remember we said that a convex lens is thicker in the middle and thinner on the edges. Suppose this is our lens, and the imaginary line that passes through the center of the lens is known as the principal axis. So this line, which seems to pass through the center of the lens, is called the principal axis. All right, principal axis. Principal axis is the imaginary line that appears to pass through the center of the lens. So that's for a convex lens. For a concave lens also, a line that seems to pass through the center of a lens. In this case, we are looking at this line here. All right. This line here is known as the principal axis. So that's our principal axis. We can also view it in the simulation here. So our principal axis in this setup is simply this line here, which appears to pass through the center of the lens. So that's our principal axis, this dotted line here. It appears to pass through the center of the lens. Yeah, so that's our principal axis here. Okay. All right, so that's one term. So what is the principal axis? We'd love to define the principal axis in relation to both convex and the concave lenses. So we are saying the principal axis definition of a principal axis is an imaginary line. It's not a real line. We just imagine that it exists. So it's an imaginary line. It's an imaginary line passing through the center of curvature. The center of curvature. As a matter of fact, it's passing through the center of a lens. But it passes through the center of curvature. which we are going to look at shortly. Center of curvature. All right, so we have defined principal axis. We are saying it's an imaginary line, assuming that this is our lens. All right, so a line that appears to pass through the center of the lens is called principal axis. It's an imaginary line. All right, so this is thought to be the center of a lens. All right, so such a line is called the principal axis. Principal axis. All right. Then we have another term which is called principal focus. Principal focus. Take note, principal focus. A principal focus, denoted by the letter F, capital F, is the point on the principal axis. It is a point on the principal axis to which rays originally parallel, to which all rays originally parallel and close to the axis converge. All right, so we are saying a principal focus is a point on the principal axis. Take note, it's a point on the principal axis to which all rays originally parallel and close to the axis converge. So it's a point where rays of light converge, all right, in a convex lens, or from which they appear to diverge in a concave lens. All right. For a convex lens, the principal axis is real, and the actual rays converge at a point. For a concave lens, the principal focus is virtual, meaning it's not real. They diverge as if they appear from a point. All right, so let's just sketch the principal focus. Supposing this is our convex lens, all right, this is our principal axis. So rays coming from somewhere this side, let's just have two of them. Upon reaching the lens here, they are going to be refracted like that. Another one will also be refracted, passing through the same. So this point is what is called the principal focus. Principal focus. All right, that's the principal focus. Remember, this is the principal axis. All right, so the principal focus is denoted by the symbol F. The symbol F. All right. If we go back to our simulation here, we can as well show. So our principal focus, principal focus is simply this point here. This is the point where the rays of light seem to converge, to meet after refraction. So these are our rays. They are meeting at some point here. So this point is the one that we refer to as principal focus. Principal focus, denoted by the letter F. Denoted by the letter F. All right, so I hope you have taken note of that. So this is our principal focus. This is the principal focus, the point where the rays seem to meet. All right, okay, I would like us to stop now.